Hello everyone, welcome to one of our essential product development videos. This one is about voltage regulators, how to choose the right one for your next design. Most of products require a voltage regulator of some kind, either a linear or switching type, making these the most commonly used components on a PCB. The first step to choose the right voltage regulator is to determine your input voltage, output voltage, and maximum output load current. While many other specifications exist, these three will get you started and will help you narrow down the type of regulator you need. These voltage regulators can be divided into two broad classifications. 1. Step-down outputs a voltage lower than the input voltage, and 2. Step-up outputs a voltage greater than the input voltage. Knowing your input and output voltages will help you to easily decide which group your regulator falls under. Voltage regulators that require an output voltage less than the input voltage are the most common type of voltage regulator. For example, you input 5V and it outputs 3.3V, or your input is 12V and it outputs 5V. There are again two types of regulators you need to consider. That is, linear regulators. These are simple, cheap, and noise-free, but may have low power efficiency. Examples are 7805, 7812, 78L05, etc. Linear regulators are only capable of stepping down a voltage. And other one is switching regulators. These are with high power efficiency, but more complex and expensive and more noise on the output. Switching regulators can be used to both step down or step up a voltage. Example for this is given here: a boost converter module with analog devices LT8330 and some components. These regulators use inductors for energy storing and manipulating purpose. The circuit diagram is also shown here for reference. Variables to consider: Vin, input voltage; Vout, output voltage; Iload, load current; Iinit, output current; In, input current; theta J, heating factor. For linear regulators, power equals Vin, Vout, X current. Assume Iinit, Iload, is approximately same as In. In practical, In equals Iut plus quotient current. Regulator consumes heat dissipation equals power x theta J. You have to add room temp to it. If regulator has a theta J spec of 50 degrees Celsius per watt, this means if your CU is 1 watt, it will heat up 50 degrees Celsius. Actual temp equals 50 degrees Celsius plus room temp. Buck boost switching regulators. If you are using 2 AA batteries 3V in your product, when fully charged output around 3.2V, and being discharged 2.4V, your voltage supply can range from 2.4V to 3.2V. Now let's assume you need an output voltage that's exactly 3V regardless of the state of the batteries. When the batteries are fully charged, output of 3.2V, you need to step down from 3.2V to 3V, and when at the time being discharged you need to step up from 2.4V to 3V. In this scenario, you could potentially use a separate buck regulator followed by a boost regulator, or vice versa to solve this problem. But it is typically best to use a single buck boost regulator. Conclusion: to choose a voltage regulator for your product, start by assuming a linear regulator can be used if the V input is higher than the V output. If that wastes much power, then use a buck switching regulator. If you need an V output higher than the input, then use a boost switching regulator. If you have a situation where the input voltage can be higher or lower than the V output, then go for a buck boost switching regulator. Finally, if you need a clean output, but need the power efficiency of a switching regulator, then use a switching regulator followed by a linear regulator to clean up the supply voltage. Few notes are given below in the description. Thanks for watching. Have a great day.